Well, hi, good morning. Thanks for joining me here in my shop for what I hope is a pretty interesting session. And hey, no cats are going to bother me today because there's 6 inches of snow on the ground outside. They do not want to go out there. And neither do I. Yeah, snow. It's a winter wonderland outside. So, the good news is I did hear from the owner of this radio, and he's given me information with which I can eliminate the concerns around how the band switch works. He just looked at the cabinet, and he's given me the order, and I've just written it here. The first thing we're going to do is we're going to go through this order with the radio, watch these band lights, and see what happens. And maybe I'm just, well, there's a really good chance that I just got everything all messed up in my head here because I can't believe this could be wrong. Even though I have all kinds of indications it is wrong. Okay, so we need to power up the radio. You know what? We only need to power it up with the 6.3 volts so the tube heaters and the lights go. We don't need to actually turn on the whole radio for this. That's great. Okay, here we go. And there we are. We have a light on already. Let me just douse some lights here. It's still not easy to see it. Oh, it's because I have this light beaming right on it. Let me just move this. There we go. The light's falling apart here. Okie dokie. So we can see which light is on. That's the main thing. And we're going to get the control here. Never mind all this stuff. Just this part here. BC counterclockwise max. So broadcast is the middle one and the light is burned out. Okay, one. There we are. You know what? I could actually go back. Let's go back and just compare the 3 lights that come on. So I think I'm on the 49 meter band. So the next one should be I'm on the broadcast band. Next one should be 49 meters. That should be this band here, which says 49 meters right here. And look, 6 megahertz, but the light did not come on. The next band should be 31. 31 meter band is this band, but the lights come on up here. This is true then. Okay, next one, 25 meter band, which is, I'm trying to read the actual, there it is, 25 meter band. And this lights come on. They are wrong. They are wrong. And the last one, 19 meter band, which of course is up here, when it's turned on this light. How the heck can that happen? That's what I would say. I mean, the easy way is the lights have been maneuvered incorrectly up here. But as I showed yesterday, the wires are really, they just don't allow for that to happen. What, didn't I say something about cats not coming in here today? I thought you were not coming in here. You don't like the snow? You can go in the garage if you want. You want to do that? You got to say something. Do you want to do that? Okay. So when they look out like that, they're telling you that's the answer. That was the answer. So I'm going to go throw her in the garage. I'll be right back in. Okay, the cats have decided to play with themselves. Oh, that's a... I think you know what I mean. And I'm going to get back to this radio now. What to do about the crazy situation here with this guy? The next question is, which band is actually coming on? Just because I know the lights are wrong, it doesn't mean the bands are going properly. Well, this is not going to work very well. So I think what I got to do now is based on the over this way, over that way. Somebody click a button. So, you know, I've realized now I know the lights are following their own pattern and not following the dial here, which is really weird. How do I know for sure the bands are following the dial? I mean, that'd be a fat chance that the bands themselves are not following this. But I gotta prove it. I gotta prove it now. That's what's going to happen today, at least to start. It shouldn't be too hard to do. This will give me a chance maybe to check the sensitivity of each band too while I'm doing this, even though I haven't done the alignment yet. Okay, let me get the radio going. You know what, the heaters are on. The radio's almost going. I'm just going to throw switches here. You know, one of the things about using the old equipment is it warms up a bit and casts just a little bit of heat. And in Canada in the winter, that's a welcome thing. So once my shop here warms up, it takes about an hour for everything to kind of get really warmed up. I can come in here, I can kind of feel the pleasant warmth of vacuum tube equipment. Now, shouldn't we be hearing something already from the radio? Do I have an antenna on it? And the answer is I have nothing hooked up to it. Let's just put a noisy antenna on it. Oh, antennas. I have 3 antennas in my backyard. I don't anymore. The windstorm came through a couple of nights ago, a very big windstorm. Took a big limb off a big tree in my backyard, and that limb took out 2 of my antennas. Ripped them right down. Broke the wires, everything. I'm down to 1 outdoor antenna now. And I don't know if I'm going to get out there and fix them up. I'll show you why. The way it works here in Aurelia is the average amount of snowfall each winter is 9 feet of snow, 3 meters of snow. It doesn't all accumulate, but it can. And it usually starts like this. Sometime in November we get a snowfall like that, and the snow never goes away. It just keeps building up. It never melts off. I think a melt is coming in a week, so this will probably all go away. But that's the main reason why my cats are not going outside. Beautiful, eh? No wind, so the snow is stuck in the trees. Fantastic. And they've actually gone off to play games together. Good for them. Okay, what's the best way of doing this then would be to simply well, there's 2 ways of doing this. One is I just tune the radio to some frequency, hit it with the signal generator, and try to make that pop out of the radio. And that would verify the radio is receiving that frequency on this band. And another way is to hunt down the local oscillator. You know, I can't imagine this is wrong, so let's just go the first way. I can't imagine this is wrong. Here we go. So first we will switch to the broadcast band. Okay, that should be broadcast band. And I didn't put the antenna on it, did I? I said I was going to use the signal generator. Like, come on. Yeah. Hey, where's the sound? Where be the sound? Oh. Maybe my amp here is not amping. The speaker's definitely working. Yeah, I got a bad connector back here. No, this isn't the reason why I thought the radio didn't work for 3 days. Just before somebody did this. She's in gear. Shouldn't we be hearing something at this point? This is turned up. Oh, no B+. No B+. That's why we can't hear it. Okay, volume's down. Volume's down. B+ on. watching that current meter again and want to not go above 25. It's just sort of a figure I picked on. See, that renders a B plus of a little over 100 volts probably through the radio. Should hear it now. I keep thinking every day I come in here this radio's going to stop working again. And I'm going to go through another 3-day journey of terror. Okay, so we think this is the 49, this is the broadcast band. Okay, I'm going to just move this over. You don't need to see the speaker for this. We are tuned and not quite in the middle, and put it roughly in the middle. Oh, that's got to be the broadcast band. I mean, wait a minute. I don't need the signal generator. Good tuned stations here. What's all that about? This is definitely the broadcast band. Put the antenna. What is so weird about that? So they put a lot of tape on the wire there. It's easy to clip onto the tape and not the... There we go. Let's just try tuning again like that. Every kind of noise you can think of, that certainly does suggest. I'm going to put the ground on, and I think we'll be able to receive at that point. Okay, put this. Okay, man. A voice. Okay. I have proven what band I'm on. Man, you're great with radios. Let's go another one step now. This should be the 49 meter band. No lights have come on. This is in order, right? 49, 31, 25, 19. Did I just show that? I didn't quite show that, did I? 49, 31, 25, 19. It's in order. Seems to me the other Westinghouse I did a couple weeks ago was not in order. Just to add more to it, the band switch jumped the bands up and down the dial. It really did, you know. I don't think it went, it didn't go like band, 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 band. It went like band, band, up here, then down here. I don't know, boy. That was strange stuff. So did I change this? I did change it, didn't I? I did. But let's just be sure here, because making a mistake at this point. Okay, 49 meter band. Now there shouldn't be anything there at this time of day on an antenna, other than the kind of noise you hear. So we're gonna do away with the antenna after putting it on. We're gonna hook up the signal generator. Trying to not get confused here by all these wires. Okay. Now, 49 meter band, the tuning pointer, I'm going to put it kind of in the middle here. 6100 is the number we're looking for. 6100. Right, 6100. Can't argue with that. Okay, band number 2, correct. And no lights are on. Band number 3. Band 3, one light is on at the 25 meter band. I'm reading it. I don't want to say what I think it is. The light is on to 25, but we are now dialed to the 31. We think we're dialed on to 31. Now, that seems a little weak. So the pointer on the 31 meter band is at 9.5. Right on the band change of my signal generator. Let's see if we can get there this way. No doubt about that. Next one, 25 meter band. Okay, this has turned a light on. Didn't I just lose track of it there? I gotta be certain. BC 49, 31, 25. It gets quieter as you go. 25 meter band. It's just a hum there. There's really no radio-ness coming through. 25 meter band. On that band, again, I've got to read it. We are at 11.8, which was 10.4 last time I remember. Watch. I bet you when this says 10.4, we're going to hear it. Can't get there. It's pretty exciting, wasn't it? Okay, here we go. 10.4. What happened? Give it a little more juice. 11.8. Nobody home? Okay, we're slamming. We're beating this radio now with a signal into the antenna. What happened to the 10.4? I got the volume turned up here. Pretty full. Band switch not making contact. Okay, so the band that's lit up is the 9 megahertz band. The 31 is lit up. And we're on the 25. 11.8, no doubt about it. But this is received before. What has happened? Okay, so it's right in the area of 10.4, I thought. Let me just wiggle the band switch here a bit. That's not helping anything. So how do we know this is really the 25 meter band? We might have to, well, process of elimination. One more band left, 19 meter. If I do the 19 meter, and it behaves properly, then we know the 25 is just simply weak. Let's go to the next one, the last one. Better be the last one. That's it, end of the road. Now we've turned on the 49 meter band light, this one right here, but really we're on the 19 meter band, and we're tuned around 15 to 40. So this is a problem here. I have to go back a couple bands and make the radio work again to convince myself it hasn't broken down in the middle of me doing this. Let's go back 2 bands. We're on the 25 meter band. No, we're on the 31 meter band now. The 25 is lit. 31 meter band, 9.5. Right at the end here. Oh. The meter's jumping. Why am I not here? Oh, it's that stupid audio plug again, I bet. Yeah, certainly is working here. Okay, turn down the volumes or we're going to get our ears blasted. Wiggle this thing. What was that? My little amp's giving up the ghost? Not really. Radio doesn't work on this band at all? No, I've had the radio receive 10.4 when I thought it was tuned to 11.8, but I had the band switch different maybe, because the bands are not right. Major confusion here now at this point. Let's go to the top band, 19. Okay, so that's a 19 meter band. You can see the light it's turning on. It's turning on this light. It should be turning on way up at the other end. Way up at the other end. These lights are on completely backwards. How could you possibly do that? Hey, I thought this would be simple. 19 meter band, why can't we hear you? We're tuned to 15.2. Dead bands, 15. And all volumes cranked here. There's just nothing more in the radio. Something more may be wrong here. What did I say we're tuned to? 15.230. It's nothing. Wow. If I move the band switch, see if I can get 15.230 to show up on some other band. It's kind of a wacko thing to do. Let's do it though. So this next band is quiet also. I mean, if this thing jumped to life, I've had it work 10.4 to 11.8 when the band light was on the band that I'm interested in. Got all that? Here we go. We're gonna there. Okay, so that there sounded like I fixed something. No. Confusion reigns. The light is on. It should not be on. We're on some other band. But I'm going to pretend we're on this band, and I'm going to try to tune 11.8, which was 10.4 in reality. Okay, let's just turn this down. And we're gonna... Okay, so 11.8 is nothing. 10.4. So, 10.4, is there another band that says 10.4 at this point? No, this radio doesn't receive 10.4 at any time. Nobody's got it. It's not on any of this. This radio should never hear 10.4. So I have two bands. I can't seem to get any signal through, but if I do, it sounds like it's another band. The frequency actually, it doesn't sound like another band, it sounds like nobody's band. Just horrendous alignment. Horrendous alignment. So, is there any reason why I should really doubt this? No. Is there any reason why I should think this radio's band-wise is wired differently? No. Is there any reason why I should think these lights are wrong? Yes. Lots of reasons why. Incidentally, these light sockets are not ordinary light sockets, if you can call any light socket ordinary. These are double insulated. So as much as you would imagine this to be a chassis potential, it's not. There's two wafers in here. This is out from the metal. It's not touching. This bracket, that's just part of the light, is insulated away. It's right in the middle here, the sandwich straight in there. It's insulated away from the positive and negative, or left and right, or up and down terminals. So it's not an ordinary socket. And that's an indication that what they're doing is they're moving the ground connections around to make the lights come on. So this light's not on because there's no ground connection. Unless the light bulb, hey, what are the chances the light bulb's good and the band switch is bad? There's something I hadn't even thought of. very, very tricky for people to not have assumptions going in their heads, because the human let me put this on the ground here, and I'm not gonna complete that thought. Here we go. So this should turn the lights on. So they're serious. So these two are burned out. Not those. So the light that's on, when it's switched on, will show a ground on the grounded terminal, which I'm going to guess is the top one. The two terminals, the top one is tied all the way along. So that's the ground. Wait a minute, that's the ground. How can you switch the ground? So that's the live. So they've used a black wire for the live, and the ground are the colored wires. Of course, the colored wires are the ones that they need to keep track of. Somebody didn't keep track of the colored wires. Then they brought this out of the factory with the lights going on. That wouldn't make it past. I'm sure the last stage on these radios before they go out for sale is somebody plays them and just goes through everything and make sure it's all working, because you can't afford to send a radio off to a store and then have the store phone up and go, the lights aren't right here. I'm sending this radio back. Remember, rework is the death of a project. I do a lot of rework in here. Rework is the death of a project. Now, let's get the voltmeter out and find out about these lights that aren't lighting. What's happening here? So I did not put my snow tires on my truck yesterday, as I said I would, but I did not. Guess what? I have to do it today. So what we're looking for is a ground connection that is floated high. So it would have 6.5 AC volts on it. Voltmeter right there. Oh, I can't get them both in view here. Yes, I can, but just back this up a little bit. Okay, so I'm gonna ground one lead here. Chassis it. I'm gonna chassis it. Lights that are off will have the 6.3 volts sitting on the bulb. Let's check that out. 6.3, 6.3. Oh. This light's not on because something's wrong with the wire. Or no, the bulb's burned out. Bulb's burned out, so the voltage is not conveyed all the way around. So burned out bulb. Well, that didn't help the situation, eh? So then if I want to know, maybe on the other side of the burned out bulb and go here. We should see the voltage? No. Ooh, did I just do that? So there's the 6.3 floating at the moving on here. Okay, so this one is grounded out, so I'm on the grounded side of the light bulb, and then I'm on the high side of the light bulb. Oh, that's good. So it is as I thought. The 6.3 volts is distributed across all the lights, and then the grounding is switched to select which light. Hey, there's no... Yeah, burned out light bulb problem again. Yeah, but the 6.3 should be sitting here waiting. Now, I think as you see a 0 on the light that's on, that's what happens to the light that's on. So here we go. Starting on the broadcast band. The light that is switched on will have a 0 show up here. Except the filament's burned out. So this is the light that should be on. So they all have 6.3 here. This part should be grounded out. If I put a light in there, the light would come on. My God, the simplest things are just really doing me in here. So you can see the ground come into place on it. So BC, turning on the BC light. Trying anyway. 49 meter band. 49 meter band. It's right there. 49 meter band. This light should be on. The ground should be here. Look at that. We got 6 volts. 6 volts. No ground. Okay, let's just keep going here. That's odd. That's in between. Now this is the second time the radio has appeared to operate between bands. Which, it just be some weird combination of this, that, and the other thing. Or it can indicate there's a problem with the. So where am I? I've lost track here. 49. Sorry, BC 49, 31. 31. That's supposed to be this band. 31 says right there. But of course, that light's come on, so we know where the ground is. It's up there. And now we know where the ground is. It's there. But now we're on. So these two appear to be just backwards. Isn't that right? Isn't that right? Is that what it is? Broadcast 49, 31. I should be here, 31, and then I should be here. These two lights are backwards. And then the last one, it is the last one, 19. No, it's not grounded. But that light's not burned out, is it? Doesn't that light come on at some point? That light does not come on, so it's burned out. So we got 6.3 supply and just some funny nonsense coming back the other way. Wait a minute, that should be a 0, right? That's supposed to go to 0 when you hit it. Oh, why am I losing my brain? What's going on? Never goes to 0. You take this one. There, it goes to 0 when the band is switched properly. And the other thing is just a floating high thing. There's never a ground placed on this? Never. Oh! Wait a minute. Wait a minute. I did have a ground, so it's just bad testing. So what I'm going to do now is I'm going to map out the current position of the lights, and then I'm going to plan how they need to be relocated to work properly. Like just, wow, and to think. People landed on the moon and I can't even sort out 6 lights. It's not even 6 lights, it's 5. Okay, I'm gonna work on that. And what a schmozzle. Okay, I think I reached the conclusion here of what has happened in this radio. So now these numbers here, 5, 4, 2, 1, those are the numbers I've written on top of these. I wrote the numbers on these lights. 1, 2, 3, 4, 5. Kind of backwards to how the bands run, but that's okay. So of course we started with the broadcast band, and it should light number 3, and it does. Number 3 is in the middle. From there, the radio goes band, 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 up. Just goes up. Dup, 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 dup. Simple. Just as you would expect. But what the lights are actually doing is going the other way. They're going 1, 2, skip 3, 4, 5. 1, 2, skip 3, 4, 5. They're just on backwards. They've been completely rotated around. And what happens is the broadcast band stays where it's supposed to stay, because it's in the middle of 5 things. So somebody has taken the lights off at some point, maybe to change light bulbs or something, and when they put them on entirely backwards. And from that day forward, this radio has made no sense to anybody who's operated it, except for the broadcast band. Now the thing is, so if you're not a skilled operator, so the band that's lit is this one, while you're listening to this band, you wouldn't even know it. You just wouldn't know it. You'd be picking up shortwave. You don't really know what you're doing anyway because you're a very casual listener. So it's possible that this radio could continue to be operated by people in the condition it's in without anybody realizing. It's totally out of whack. Totally ass backwards, basically. Now, how did they manage to do this? Because when I studied the wires, it didn't look like there was any way that could happen. It still looks like there's just no way you could get these backwards. I can't take them off, rotate them around, put them back on. Like this guy has to go all the way to here. Let's take a closer look at the wiring here and see what we really got happening. See, I think I'm just so the radio is operating in terms of 6.3 volts right now, but I turned the high voltage off because we don't really need it. Let's take a look. Oh, you're looking at me. Let's force a little focus here. Just 1 second. So what we're interested in now is, well, how much slack is there in these wires? In fact, let me hold this camera now. So here's where they come out of the hole. And here's where they go in the back. I mean, there's no slack to pull up. There's just nothing. There's no slack. You can hardly even see where the hole is. It's right there. There's the hole. There's no way there's slack in the radio. So this is what we got. We got this. No particular slack in them. All the way up. Now we should probably have one wire coming up to intercept all these black ones here. And I think it's way over here. This one here. So if I were making this radio, I would make this wire attach here because it's less wire. Somebody already pulled the slack out of the radio. They already pulled it out, and that enabled them to put these on backwards. Does that make sense? So then the colored wires are all the switch wires. Well, they're also going to be cut to length. Now look at there. There's no slack. So, and sure, I can move the lights out here. So, did somebody rewire this entirely? Is that what happened? They couldn't have. They couldn't have. These are original wires. What's that funny bend in that wire for? This wire. These wires are stiff as can be too. I'm not doing anything much with them. In fact, if I take one of these lights off and try to, two of them and swap them around, it can't be done. Like, what did I figure had to be swapped? It was 1 and 4, wasn't it? No, 2 and 5. 2 and 5. These two have to be swapped. I shouldn't put my fingers on it like that. Well, there's no hope. Oh my God, did this come out of the factory like this? No. Did somebody grab the lights from another radio? No, why would they say no. Is there any way to see that these aren't original? Look, those wires that come in the back here, the ones that are carrying the power to the light that's going to operate, comes along here. Look at it, and it just dives into the switch here. And now we're back to the switch being 180 degrees out. Could that be it? Could the so what I'm saying is the switch in there is driven by that flat shaft in between the two circular shafts, right? And it can be inserted or the wafer can be rotated 180 degrees and the shaft will go through it. Now, what are the chances of that? It's so small. You see, it's not loose. You can see it's fit right in there. And so which ones are the lights? Now, a lot of these wafers have two sides. Looks like there is a back. Looks like the backside terminals here. Not necessarily. You can study in the schematic and find out if this is a lights only thing. Are any wiring changes visible in there? What's that bare wire going way down through that hole there? There's something more going on with the switch. So I think it's probably one side's doing, yeah, look, there's coils hooked up to it. So it's the front side way in there. And there's just no hope of me doing anything in that. And no one else would have done anything in there. Man alive. The simplest of problems turns into a monster. This is a monster. So now what I'm down to is really rewiring this thing in order to get the right lights in the right place. Hold on, camera, will you just sit still here for me? Frustration running high. I really thought this would be a simple matter here. So looking at it very carefully, yes, I see the positive feed wire. Oh, there's two. It looks like it's fed from both ends of the. Why would they do that? So it looks like there's two black wires coming up. Let me point to them so you know for sure what I'm talking about here. So, see in the bundle, there's two black wires. One of them's coming right around to here. And then you can see the wire loop like a jumper, and a jumper, and a jumper, and then a jumper. But then instead of ending there's another black wire that comes back. Why would they do that? That's a waste of a wire. Why would they do that? And I don't hear any answers, so I'm going to carry on here. So here we have the colored wires, and much of the coloring is gone. There's a colored wire here. This could be green. In fact, this could have originally been green. So the colored wires, are identified in the, and you can certainly see the red one there. They're identified in the schematic. Well, let's stop for a minute. I'm going to study up on that schematic. What's it feel like as you're sliding down a rabbit hole? It feels like this. So here's the switch for the lights right here. Now look at this thing. So here's the 6.3 winding. There's the ground. This is the high side. The high side is switched. But I convinced myself it was the ground side that was switched. I put my meter on the chassis, and the other lead finds 6.3 volts on the lights that are switched off because they're not grounded like it's shown here. I'm gonna start seeing rabbits at any moment here because I'm way down the hole now. So, you know, this is what you would expect, right? You would expect them to switch the high side, not be switching grounds. I don't know why they would bother doing it the other way. Or if I just misinterpreted the thing. No, because I can find 6.3 volts all across these. All the time. Wow. So the switch is selecting a wire, goes to the light bulb, and applies the power. So these lights should show zeros because they're just on the ground, and I have my meter connected to the ground, to the chassis. The meter is connected to the chassis. After seeing this, I have to repeat the test. So the name of the game here is that the positive is being, the voltage, it's AC, the voltage is being switched, not the ground. That means if I have one light on, and I currently have one light on, that's this one, and we should see 6.5 volts there, but not anywhere else. So there's the 6 on the on coming to the light, and the what about the other lights? They've all got 6 coming to them. Of course, because I can see the black wire looping along. They don't have grounds on them. Well, you know what? I don't know what to do. I really don't. I'm just, I'm trying to avoid doing unnecessary work here. I'm trying to avoid making a misinterpretation, doing a pile of work, and maybe in the end actually making things worse than better because I haven't understood something. But what can I not be understanding at this point? I beat this issue to death. It's just so weird. It is so weird. I think I'm going to end my video on that note. Yeah, I think I'm going to end it there because I've got 4 snow tires waiting for me here. Well, thanks a lot for watching, and I hope you're getting a kick out of this. You know, this is what fun looks like when you're fixing these radios. So I'll see you tomorrow.